If you think about the Earth's atmosphere, it's basically a thin layer of gases that surrounds our entire planet, made up mostly of nitrogen, but also with a fair bit of oxygen, which allows us to breathe. It also contains the greenhouse gases that keep the planet warm, and the ozone layer, which keeps out the most harmful radiation. Importantly though, the density of the gas particles is highest near the Earth's surface, and the pressure then gets smaller and smaller the further away from the Earth you get. In this video, we're looking at atmospheric pressure. And this idea of the density decreasing as you get further and further away from the Earth is one of the main reasons why atmospheric pressure also decreases the higher up you go. We can see this if we plot a graph of atmospheric pressure against elevation above sea level. If we compare an object at sea level to the same object at 1,000 meters up in the air, then there's going to be a lot more air particles around the object which is at sea level. And this means that there'll be a lot more collisions with the surface of this sea level object than there would the object which is really high up. And if there's more collisions, there's also going to be a greater force overall, which if we look at our pressure equation, we can tell will create a higher pressure, because a bigger force means a bigger pressure. So in summary, because there's a lot more particles closer to the Earth, any object that's closer to the Earth is going to feel much more pressure, because all those particles are going to be constantly colliding with it. The other factor that determines the pressure, though, is the weight of all the gas particles above the object. An object at sea level is effectively at the very bottom of the atmosphere, and so will have a huge weight pressing down on it, because of the weight of all those particles above it. And as weight is just another force that will contribute to its pressure. On the other hand, this surface at 1,000 meters up in the air will have a lot fewer particles above it, and so the force of weight will be smaller. This change in pressure as you get higher up in the atmosphere is the reason why mountain climbers have to carry oxygen cylinders. The air is so thin that there's literally not enough oxygen to breathe.